Hi everyone, welcome to Vedantu JEE English. I am Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I am clearly visible and audible to you so that we can start with today's session. Yes students, everybody in the chat box. So let's start with today's class, and today we are going to start with alcohol, phenols and ethers. Right, and by this week we are going to finish this particular chapter as well, right? So till now we have completed GOC complete, we have done isomerism as well, IUPAC naming as well. We have also done hydrocarbons and haloalkanes, halorines in detail, right? So today we'll be starting with alcohol, phenols, and today our focus is going to be on preparation, physical and chemical properties of alcohol. In the next class we'll discuss about phenols, and next will be for ethers. Yes everybody, so let's start this session. Yes Manoj, Varsha, Single, very good everybody in the chat box. And now let's start this particular session because it's a very important thing, and you will see that now as we are approaching towards the third lecture of organic chemistry, you will feel more enthusiastic. Why? Because already the reactions that you have seen before, those type of reactions will be repeated again. So you are going to have a fun session today. Don't worry about anything. Let's start it now only. Thank you so much Manoj, thank you so much. So let's spam the chat box with green hearts, and I want you guys to stay fully focused here till 6 p.m. or maybe 6:10, 6:15 p.m. 1.5 hour class it is going to be. So let's see how much we are able to complete, because after this you will have your maths class. So let's see how much we are going to do that, right? So firstly, before that, I don't know how many of you have given offline MBSAT program. Now there are some students who were asking, ma'am, but we are not able to go to any offline center, ma'am. Is it possible? Ma'am, it is not near us. Vedantu center is not near us, or ma'am, it is very difficult for us to, go to the Vedantu center and then give the test. Ma'am, is there any possibility that we can give this test online? So yes, now we have, especially on your demand, MBSAT online, right? That means you're just sitting at your home and you're able to give that, right? So now here the dates are 21st to 28th of October, and the registration has now started, guys. Everything else is going to be same, that among students who are among 2.5 lakh, and they will get up to 100% scholarship, 150 crore worth of scholarship and 2 crore worth of rewards and prizes you will get here. So these things you will get, but here at the comfort of your home you can give this test. Link is in the description box. Click on that and give that, right? Okay, yes everybody, do let me know, right? So those students who were like not sure, wait a minute, yes, wait a minute, yes. So this is for those students especially who are not able to visit any other city and give the test, right? Okay, so now let's start with the introduction of alcohols, right? So starting with the introduction of alcohols, what we have here, same just like haloalkanes, halorines, this will go. Right, alcohol, phenols and ethers. First we will distinguish what is alcohol, what is phenol, what is ether. Alcohol is when from the alkane you substitute one hydrogen with OH, that is alcohol. When from the benzene one hydrogen is substituted with the OH, that is called as phenol, right? And when we talk about esters, that is esters I am saying, when we talk about ether, that is ROR, that we are going to talk about in the third lecture, right? So now firstly let's discuss the classification of alcohols, right? So firstly, based on the number of OH group that are present in the molecule, it is divided into 4 categories. First is if there is only one OH, that is called as monohydric, that means only one OH is there. Dihydric means 2 OH groups are there. Trihydric means 3 OH groups are there. And when we talk about polyhydric, that means more than 3 OH groups are there, that is called as polyhydric. Hydric means the number of OH groups here. Now, remember that ethylene glycol and glycerol are very important structures, right? These are two very important structures. You should know as it is their common name as well. These are the common names. This CH2OH, CH2OH is ethylene glycol, and when you attach one more CHOH here, that will become glycerol. Okay, ethylene glycol has 2 OH groups and glycerol has 3 OH group on the adjacent carbons, right? So that is ethylene glycol and glycerol. Now this sorbitol is also in your syllabus, so you can just, because this is in your NCERT, so that's why this becomes important for you. But otherwise remembering the structure as it is not that important for you, but these two are important, right? Okay. Now, let's talk about the IUPAC naming. Now some other IUPAC naming, guys, I'm not going to discuss, right, because we have already done a good lecture on IUPAC naming individually. So, we are going to see some of the common names here. Like here, polyhydric ethylene glycol, this is propylene glycol, when 2 adjacent carbon has OH, but total there are 3 carbons, that is propylene glycol. And what is glycerol? When here also you have one OH, that becomes glycerol. So these 3 are important common names to remember, right? Throughout your organic chemistry, these are important names to remember that you must remember for your upcoming lectures, right? Because in aldehyde, ketones and carboxylic acid, the use of alcohol, phenol, ether is too much, right? So you have to go through that in a sequence, right? So classification, second classification is how monohydric alcohols are classified on different bases. First is compound containing sp3, right? Just like we discussed about haloalkanes, similarly we are going to discuss about alcohols, right? So when the OH group is attached to that carbon which is further attached to only one carbon, that is primary. Right? When the OH group is attached to that carbon which is further attached to 2 carbons, that is secondary. When OH group is attached to that carbon which is further attached to 3 carbons, that is tertiary. So primary, secondary and tertiary, these are the 3 classification based on the number of carbon that is connected to the carbon of OH. That will define the primary, secondary and tertiary. Then we will talk about that allylic alcohols. Allylic alcohols are where next to the double bond you will have a carbon and OH is attached to that carbon. Next to the double bond you will have a carbon and OH is attached to that carbon. Next to double bond you have a carbon and OH is attached to that carbon. Okay, that is allylic. That means simple C double bond C, this is OH and this is this is okay, right? So this is your allylic carbon. When something is attached to the allylic carbon, that is called as allylic, right? So for example, you have halogen attached, that will be allylic halogen compound. This is allylic alcohol compound. Now if this carbon is connected to only one carbon, that is primary. If this carbon is connected to further 2 carbon, that is secondary allylic. If this carbon is connected to further 3 carbons, that is tertiary allylic. So 3 kinds of, see now allylic also we have divided into primary, secondary and tertiary. Okay. Oops, just give me a second, guys. Wait a minute. Okay. Yes. So this is further divided into primary, secondary and tertiary allylic. Guys, tell me if that thing is clear. What is primary, secondary, tertiary? What is allylic primary, secondary, tertiary? Now we'll talk about benzilic. Benzilic is when you have a benzene ring. And we are not saying directly attached to benzene ring. To the benzene ring, you will have the attachment of a carbon. And to that carbon, it is connected. This is called as benzilic alcohols, right? So now benzilic alcohols are divided into again 3 categories. If this carbon that is connected to OH is connected to only one carbon, that is primary benzilic. If this carbon that is connected to OH is connected to 2 carbon, that is secondary benzilic. If this carbon that is connected to OH is connected to 3 more carbons, that is called as tertiary benzilic, right? Now, next is when the OH group is connected to a carbon which is sp2 hybridized. It is not sp3, it is sp2 hybridized. That means it is directly connected to a carbon which is having a double bond, right? So now here you have a double bond here and it is directly connected to that carbon which is having a double bond, and that is the reason this is called as vinylic, okay, vinylic alcohol. Okay, so now this particular OH, when you connect it, this is also called as benzilic, right, because it is directly, no, this is not benzilic, this is actually arylic, because when directly to the benzene ring OH is connected, that is aryl, okay. But here, if you see only this particular part, this can also be regarded as vinylic, okay. Yes, everybody understood, right? Now let's see some nomenclature of alcohols. I think this is the third time in every first lecture we do this, so I'll just do this fast. It's the third time we are discussing this, third or fourth time we are discussing this. So starting of every chapter, that's why I don't know why students find organic chemistry difficult. Every single chapter is related to each other. So how can you find it tough, right? It's like if you do organic chemistry, it will definitely never leave your side. You will definitely do correct answers there, right? So here guys, if you have a normal chain, that is called as N, right? That's why here 3 carbon and it's a normal chain. There is no branching here, then it is N, right? If there is a branching in which there is a carbon which is connected to 2 methyl group, that particular group is called as iso. This particular group is called as iso. So this is iso because there are 3 carbons, so it is isopropyl alcohol, right? Now here if you see, this is tert, this is not neo, this is tert. Why this is tert, why this is not neo? Because in neo you should have 3 methyl groups and basically carbon should be connected to 4 carbons, out of which 3 definitely should be the methyl groups, right? That is called as neo. This particular situation is neo. And this particular situation where you have any group, any carbon that is connected to 2 methyl groups, that particular situation, this particular situation is called as iso. Okay, so that's how you define iso. Inorganic is going to be difficult, ma'am, especially DNF block. Don't worry, DNF block, Manoj, I have already done. So go and watch the lecture. I have done it in detail. I think 3 or 4 lectures I have done it for that. It's in detail, right? And P block, I'm going to start. Firstly, let's complete organic chemistry. Then we are going to just kill P block as well. Don't worry about that, right? Okay, so now let's start with the preparation of alcohols. Yes, students, do let me know if you all are ready for preparation of alcohols. Preparation of alcohols. So, it can be prepared from various methods that you can see here. From alkanes, from alkenes, then alkenes, most of these things you have already done. If you see, most of these reactions you have already done. Acid catalyzed, oxymercuration, hydroboration, preparation of diols. This one will see, this one will see, this one also you have done, but we'll see that in detail as well. Then preparation of diols, from this one will be new for you. Peroxy acid is a very important reaction and this is new for you, right? Then we'll do from alkyl halides. We have already done haloalkanes, haloarenes, and this one also will be a repeated kind of thing for you, right? Then from Grignard reagent will be new for you, right? By reduction of organic compound will also be new for you, okay? So these, some of the reactions will be new, Some of the reactions will be repeated. So we'll see that the reactions that we have already done will not focus on that, will focus on those reactions which I have not done in the previous lecture. So this is what I have told you, how they are interconnected to each other, right? Okay, everybody. So let's start with alkanes, right? So I am starting with alkanes. See, from alkanes, if you want to prepare alcohols, right? First you need to see one thing here, that if I say this is alkane, right, then here it will be converted to alcohol on oxidizing agent. Then further oxidation will give you aldehyde or ketone. Then if you further oxidize it, it will give you carboxylic acid. Okay, and if you further you want to further oxidize it, it will give you CO2 plus H2. Now in the forward direction there is oxidizing agent that we are using, oxidizing agent, right? Oxidizing agents. In the backward direction, if you see, if I want to convert this to this is not possible, right? If I want to convert carboxylic acid to aldehyde, I will use reducing agent. Aldehyde or ketone to alcohol, I will use reducing agent. Then if I want to convert alcohol to alkane, I will use reducing agent, right? Okay. So can you see one thing? Alcohol can be formed by two things. Either for alkane you use oxidizing agent, you will become alcohol, you will have alcohol, or from aldehyde ketone you use any reducing agent, or maybe carboxylic acid is converted to alcohol if you use a very strong reducing agent, right? So that means that is the idea of oxidizing and reducing agents, how they are used, right? So let's understand that, right? So that's why this reduction of organic compound using this will do in the reverse manner. Reduction, if you want to do the reduction, you can only use from aldehyde ketones, then or from carboxylic acid, or maybe from the derivative of carboxylic acid you can prepare alcohol, right? But with the oxidation you can only prepare it from alkane, right? There is no other thing here. So from alkane you will use oxidizing agent. Let's talk about that. So if you use oxidizing agent and this is a controlled oxidation where you are using KMnO4, which is a very strong oxidizing agent. Now you will say, ma'am, it's a very strong oxidizing agent, ma'am. Then strong oxidizing agent, ma'am, should directly convert this alkane to maybe aldehyde or ketone, or ma'am, maybe to carboxylic acid. But if you see this here they have taken tertiary alkane. Tertiary alkane, even in the presence of strong oxidizing agent, is converted to tertiary alcohol. That means it's this kind of situation. So you have this CH3, this CH3, this CH3, and this is H here. This is directly converted to CH3, CH3, right? CH3, right? And this is OH, right? And this is OH, right? Okay, and here this hydrogen is directly converted to this OH here. That you can see why it is controlled oxidation. The reason being we are using here 3 degree alkane. If we use 2 degree alkane where this carbon is connected to only two CH3, that means if we have something like this CH3, this is H and this is H. Now these two will be converted to OH and OH, then this will be converted to double bond O. So then it will be converted to ketone or aldehyde, right? So that's why with KMnO4 if you want to prepare alcohol, you only can use 3 degree alkane here. You can't use 2 degree or 1 degree alkane here, right? Okay, understood everybody? That is the oxidation part. That is the oxidation, ouch. So sorry. Wait a minute, I think. Wait a minute. Okay, that's fine. Okay, yes. So, now that was from alkane. Now let's talk about from alkenes how it can be prepared. So from alkenes, if you remember in the chemical properties of alkene, we have done this. There are three methods of preparing alcohols, right? First is acid catalyzed hydration. Second is hydroboration, oxidation. Third is oxymercuration, demercuration, and products may be different in all the three cases because the way the mechanism works is very different in these three processes. So in the acid catalyzed hydration, there is the formation of carbocation. So that depends upon the carbocation, right? And here rearrangement of carbocation will also take place. Rearrangement of carbocation will also take place in the case of acid catalyzed hydration. And what is the reaction, right? This is from the acid, this is from the acid, right? And this is hydration, and this is your alkene part, right? So let's see how do we actually do this. So this I have already told you, but still I am repeating it. You have water, right? What will happen? This water, when it accepts H positive, it will have this oxygen with the lone pair is going to accept the H positive, and oxygen, because of three bonds, will have positive charge. Now this particular pi electrons will attack here, this electron will shift here, and water will be eliminated, and you will have the addition of hydrogen here, right? Then carbocation is formed, and that is the reason here rearrangement of carbocation can also take place, and after that you will have the addition of again OH2 here, right? Again that will be added. When this is added, this O, this H, and this positive will be now here, because this oxygen has three bonds, okay? Here carbon had three bonds, this has one because it has deficiency. When oxygen with water attacks here, this has this thing, right? Then this H positive will leave and the electrons will shift here, and hence you will have the formation of, so basically here what will happen, this is OH, this H positive will leave and the electrons will shift here in the next step, okay? So this particular H positive will leave and these electrons are going to shift here, and hence you will have the formation of alcohols, right? Now what you need to remember is that in case of acid catalyzed hydration, rearrangement is possible because of the carbocation here, right? It follows Markovnikov addition, but not directly you will make a Markovnikov product. Firstly, you will always form a carbocation and then you will try to rearrange it, and it's a very important question, right? That rearrangement, directly you can't apply Markovnikov rule here. Firstly, you will cause the rearrangement. If possible, only then you will get the answer, okay? Rearrangement can be based on ring expansion, ring contraction, or it can be simple rearrangement because of the more stability of carbocation. Any case can be there, but rearrangement has to be there if it is possible, right? Okay, everybody. So this is the alkene part. Now next step is oxymercuration, demercuration, and in this case there is no carbocation. Write it. I am writing some of the very important lines here. No carbocation, no rearrangement, but it follows Markovnikov addition. So Markovnikov addition you will use, but there is no rearrangement, no carbocation that is there. So that means negative part will be attached to less number of hydrogen. So negative part, that is OH, is attached to less number of hydrogen and positive is attached here. This will be converted to single bond, and that will be your answer, right? So no carbocation, it follows Markovnikov's two-step mechanism and anti-addition of water. Let's see how, okay? Let's see how there is anti-addition of the this OH and H group, okay? Let's understand that, right? Wait a minute. That will be, okay. Chalo, let me just teach you about anti-addition here, right? So what will happen in this case, actually in case of, I'll just show you this here only. actually a cyclic intermediate will be formed here like this. That is why what will happen, the other attack will be, that means when OH is attacking, it will be attacking from this side, from the opposite side, right? And that is the reason anti-addition takes place, that if hydrogen is getting added from this side, OH will get added to from this side. So they are always anti to each other, how they are attacking, right? Okay? Yes, everybody? Next is hydroboration oxidation. In this, always directly you will follow anti-Markovnikov addition. This with a mechanism also we have done before as well. In alkenes also we have done. We have also done the hydroboration oxidation of alkenes in hydrocarbons, right? So here anti-Markovnikov addition, that means here negative part is attached to more number of hydrogens. Okay? Here negative part is attached to more number of hydrogens. So here you will have OH and here you will have H. That will be there. Okay, CH3, CH2, CH2OH, that will be there, and this is going to be your answer here, right? Okay, everybody. Ma'am, came in a strong oxidation, it is possible to get this. Manoj, I have already done instead of getting alcohol. No, for 3 degree that is not possible, Manoj. Okay, yes. Now, hydroboration is a syn addition. That means both will attack from the same side. If H is attacking from this side, then OH is also attaching from this side. That is a syn addition. Okay. So, this hydroboration oxidation is a syn addition. Then no carbocation is there and it follows anti-Markovnikov addition. Okay. Anti-Markovnikov rule is applied here. So, these were the 3 cases of hydration from where anti-Markovnikov, Markovnikov, and most confusing part is where to use Markovnikov, where to use rearrangement of carbocation. So, that you should remember in acid catalyzed carbocation rearrangement. In Oxymercuration, demercuration, simple Markovnikov with no carbocation. In hydroboration oxidation, there is anti-Markovnikov rule that is applied. Okay. Now, let's talk about by the action of cold dilute KMNO4, right? So, this is a very, very famous reaction, that is Beer's test. So, Beer's test is actually the test of unsaturation. This is also the 3rd time we are repeating this, right? So, test of unsaturation, we will predict that where if there is any pi bond present here or not. And here that pi bond will break and you will have the formation of diols, right? And that too vicinal diols you will have here, right? Vicinal diols mean on the 2 adjacent carbons you will have the attachment of OH, and that is going to be a syn dihydroxylation. That means this is going to be a syn addition. Okay, this is also going to be a syn addition. Do you remember syn and anti how we are going to use? Do you remember cis, trans, syn, anti, erythro, therio? I told you this in hydrocarbons. I have already taught you this in hydrocarbons. Okay, so how I am mentioning everywhere syn addition, anti addition, you have to use that somewhere, right? So especially if you are preparing for JEE Advanced, you have to use that, right? Erythro, where therio will be formed based on cis, trans, anti, syn, that will be there, right? Okay. Syn addition means what will happen? You will have MnO4 negative, right? So here a cyclic product will be formed. Firstly, this carbon will, what will happen? This bond will shift here, this carbon will attack here, this bond will shift here, this pi bond will attack here, and that's how a cyclic product will be formed here, right? And that is why here this bond will break, this bond will break, here you will have H, here you will have H, and that is why this is a syn addition here, right? Alternatively, osmium oxide can also be used for this particular reaction. KMNO4 or osmium oxide, both are going to give you the same answer here. That is vicinal diols with the syn addition. So, osmium oxide, that is OSO4, will give you the same syn addition diols. okay. Syn addition diols will be given by osmium oxide as well. In the same way, it will form the cyclic structure. How? Firstly, these pi bonds are going to, wait a minute, how this is going to show, wait a minute, wait. So how this is going to show this particular reaction, let's talk about that, right? So this is going to firstly attack here, this bond is going to shift here, this bond is going to shift here, okay? And that's how this is going to work. So see, there will be a single bond here with oxygen, osmium, this bond will shift here, right? And that's how you will have a cyclic structure that is formed. And same, this particular bond will break here, HH will be attached and you will have the formation of syn addition diol, right? Very good. Cis syn is erythro, anti-trans is thereo. Nahin, anti-trans is not who? No, Manoj, you need to watch that lecture again. I told you that cis is positive, trans is negative, syn is positive and anti is negative. Sorry, So whenever you have positive or negative, that will be erythro. When you have positive negative, that will be thereo. That I told you. Okay, if you remember that. Okay, this I told you. Go and watch the lecture of hydrocarbons again. Okay, yes. Okay, now this is a very important question, that is anti-dihydroxylation. So syn dehydroxylation was there in KMNO4, or in case of osmium oxide you have syn dehydroxylation, I am saying dihydroxylation, right? Dehydroxylation means to take out, di means to give, right? So two hydroxyl groups you are adding, right? So when you are adding on the syn positions, that means both are coming from the same direction. And when they are anti, one is coming from this side, other is coming from this side, that is anti-dihydroxylation, and that will be with any peroxide linkage, acid peroxide linkage, that is this kind of thing we are talking about. This is, acid is what? Acid is C double bond O, OH. And when you have a peroxide bond here, that is called as peroxy acids, okay? This is called as peroxy acid, right? Peroxy acid will break the pi bond and you will have OH on the anti positions to each other, right? That will be your answer. And guys, here, what are the different kinds of peroxy acids that you can have is these one. Peracetic acid, when you have CH3, C double bond O, you just look for this thing, okay? Just look for this thing. Trifluoroperacetic means this hydrogen is replaced by fluorine here. Again, you have this particular thing, right? Then you MCPBA, metachloro, on the meta position you have chloro. Peroxybenzoic acid. Benzoic acid is what? Just have to, this is benzoic acid, OH. If it is peroxy, this will be OH. Metachloro means this. Metachloroperoxybenzoic acid, this will become, and that is MCPBA, and this is a very important reagent, right? Directly the questions are asked based on MPBA. Okay, yes, very good, okay, understood? This is what you have to look for here, right? This is what you have to look for here, right? The mechanism is that in this case what will happen, a cyclic product is formed here, but after the formation of the cyclic product, in any of the case, any peroxy acid, what will happen, when this is formed, another water will attack here and this particular will shift here and this will give rise to O negative and that will be OH, and that is how they are anti to each other. In that case, if you see, in this case, what is happening? Cyclic, right, with two oxygen is directly attached here. So this will break, HH, you will have, that is syn addition. But in this case, what will happen? In this case, what is happening? This is C double bond O, OH. This is your peroxy bond that is there, right? So what will happen, this particular bond is shifting here, right? Wait a minute, yes, this bond shifts here, right? This pi bond will attack here so that this links here, right? And this particular bond will also attack here, and that's how you will have the linkage of this particular cyclic linkage will be there, and from here COOH will be eliminated, right? This particular thing will be eliminated, OOH will be eliminated here. This oxygen will be linked here. From the peroxy acid, it will donate the oxygen by a cyclic formation, cyclic ring formation. Then water will attack on the carbon. This bond will shift here. You will have O negative. They are anti to each other if you see. This OH and this O negative are anti to each other. And that's how anti-dihydroxylation is going to form. Right? Okay. No, Ramaraju, you can't skip. Oi hoi. What? Here I have already sent it to the team. I don't know why it is not. I have already sent it to the team. Your resonance though, it's been a long. There it was not uploaded in the PDF. It's been, I think, 10 days I have already sent it. Right? I'll ask the team if it was being uploaded or not. Right? So, yes. Okay. Yeah, it looks same as onolysis. Yeah, but it doesn't look actually same. Right? There it was this kind of situation. Right? That was ozonolite. Right? Here you don't have two oxygens here. Right? Okay, yes, this particular part looks the same, right? Now, let's talk about next one. Now, this is MCBPA. Now, directly what you will do, if one OH is attached here, other OH will be attached here. So, it will be anti to each other, right? And the mirror image of this, that means one OH here and one OH here will be formed here. That means mirror image will be formed here, okay? Now, let's see some of the questions here, that is the product of acid catalyzed hydration 2-phenyl propene, okay. This is 2-phenyl, this is 1, 2, 3, 2-phenyl, on this position you have phenyl, on this position you have phenyl, right. The product of acid catalyzed 2-phenyl propene is, right, acid catalyzed. Guys, see, acid catalyzed. So, first thing is propene means here you will have one double bond. If here you have double bond, this should be CH2 and this should be CH. Okay. So, what I will do, this will be C, this will be double bond, this is CH2. Okay. This thing will be there, right. Now guys, see, from here what you are going to do, it is going to break the pi bond and carbocation will be formed. So, where I will form the carbocation, I will form the carbocation over here, because of the resonance it will become more stable, right. Now, if you see, I don't need to shift it anywhere because already here you have the resonance. Why I am not putting positive here? Because here you don't have any resonance with the benzene ring. But here when you put positive, it will have resonance with the benzene ring. So, I will put hydrogen here, right, and this will be OH. So, you will have 2 alcohol. That means 2-phenyl, 2-propanol will be formed here, right. So, answer will be C is the correct answer. All you have to see is, you have to check which one will be more stable here. So, 2-phenyl, 2-propanol will be formed. So, C is going to be the correct answer here. Yes, everybody, next question is, oxymercuration, demercuration produces which of the following? Oxy is in resonance, 3 degree, more stable. Yes, very good. Last chance to give MVSAT, guys. It is, if you have not done, it is online, right? Still you have chance, but that is online, okay? That is the last chance. After that, there will be no MVSAT. Till offline, though, it is already done, right? But online, we are still left with that, right? So, here, oxymercuration, demercuration, we know that it follows Markovnikov addition. So, you don't make any carbocation is not formed. Less number of oxygen OH is attached, this hydrogen will be attached. So, you will have the formation of this particular A structure here, right? To less number, directly you will apply Markovnikov addition here, and this will be formed. A is going to be the correct answer here. Yes, okay everybody, understood? Next is KMNO4. This is JEE Mains 2019 question that says that Deepak, by this thing na, your JEE paper will definitely not love you, right? I don't know about other people, but your JEE paper will not love you, and your college also will not love you. Your placements will to hate you, right? And money will also start hating you, right? So it's better to love money, and it's better to love education, knowledge, right, than doing all these stupidities here, right? So here you have KMNO4H2O, guys. What is this? This is Beer's test, right? This is Beer's test of unsaturation. OH syn addition will be there. OH syn addition, guys, will be there. So what is X? Here they are asking you what is X. Okay, this is what is the question that I don't know? What is X or what is Y they are asking you? See, X will be this thing. X will be syn addition. This is syn addition, syn dihydroxylation. This is anti-dihydroxylation. So Y will give you anti, that means one is solid, one is dash. Yes, that is correct. And this will give you syn, that is also correct. So both B and C is the correct answer here. So D is the correct answer here. Okay guys, so D is going to be the correct answer in this case. Is that clear to everybody or not? Is that clear, students? Is that clear? Right, so it is going to be, Achha guys, tell me what is the time, because my watch is so there, no? Okay, cool. Right, so let's talk about next part here. That is next part here. Okay, this solution and all we have done, right? Okay, next is from alkyl halides, how it will be prepared, right? So alkyl halide, all the reactions of haloalkanes, if you remember, we have done that, right? So here when you have an alkyl halide and you use aqueous KOH, this halogen will be replaced by OH. Okay, and that's how alkyl halide to alcohol is converted. Other reactions are from Grignard reagent, right? From Grignard reagent. See, Grignard reagent, again, two types of reaction it shows. First is proton source, right? It is like proton source. Where is proton source? It sees a proton source and it will give up, right? Right at the point it will give up, right? So it will abstract the proton and itself get converted to alkane. That we have done. Now, this particular reactions are very important, that I have told you before also that we will do this in alcohol phenols, and now we are doing that. The reaction of Grignard reagent with the carbonyl compound to give you primary, secondary or the tertiary alcohol. Let's talk about that, how it is going to happen, right? So basically we know that this R part is negative, this MgBr part is positive. So this R part is going to attack on the electron deficient carbon and the electrons are going to shift here, and hence you will have the formation of this carbon here. This is O negative. This will be 1, 2, 3, 2 are already there, and this R will be attached here, and this MgX will be attached here. After further hydrolysis, this will be converted to OH. Now it depends that here if you have R and H, this will be secondary. If here you have two hydrogens, then it will be primary. And if here already you have two alkyls, then it will be tertiary. I'll show you how. Okay, so how it defines. So if you have formaldehyde, right, then what will happen? This will attack here, these electrons will shift here. You will have the formation of HCO negative. This is MgX positive. This is already H and this is R part here. Then after hydrolysis, you will have C. This is H, this is H, this is R, and this is OH. So that is RCH to OH, that is nothing but it is primary alcohol. So in this reaction, methanol gives primary alcohol, But if you have any other aldehyde, while any other aldehyde will give you secondary alcohol, why? Because in any other aldehyde, apart from this hydrogen, you will have a alkyl group here, right? So when this attacks here, these electrons will shift here, right? What you will have is, this is R dash, this is CO negative, this is H, and this R will attached here, right? And this will be MgX, and this is positive. Now after the hydrolysis, you will have OH here, this is R dash, this is R, right? And this is H. So can you see here, OH is connected to that carbon which is further connected to two more alkyl groups or carbon. This is 2 degree alcohol is formed in case of any other aldehyde except from methanol, right? Then the third part is when this R negative will attack here, electrons will shift here, and hence you will have, this is ketone, okay? So with ketone, this is R dash, this is C, this is R double dash, this is O negative, MgX positive, and this is R is attached here. Then after hydrolysis, this is R dash, this is C, R double dash, this is R, and this is OH. So 3 degree alcohols will be formed in this case, okay? Yes, everybody? How sweet, thank you, right? So guys, just give me a minute, I just need to charge my phone, right? Because some urgent phone can be there, and then people in my life will get tensed, okay? So just give me a second, I'll just charge this phone. Just give me a second. Okay, yes everybody, so that was from Grignard reagent. Do let me know, ma'am, they will ask in intermediate majorly in the same type of questions came from carboxylic back. That's why I am focusing on that thing, that where you will have anti-addition, syn addition, right? Then because that is based on intermediate only, right? Okay. Chalo. Mechanism you should know how it is done. Now guys, let's talk about if you want to make alcohols but from a different way, that is from epoxides, right? When you have epoxides are cyclic ethers. Simple ethers are ROR. Cyclic ethers are in a chain. So this is epoxide. Now in this case, you have any Grignard reagent that will attack here, and this particular bond will shift here. So what will happen? CH3, C, and OH. CH3, for example, let's say we are not fixing it that this is CH3, okay? I am not fixing that this is CH3. I am not fixing that this is CH3. I am just saying this is simple RMgX, okay? This is simple RMgX, okay? So this is negative, this is positive, this negative part will attack here, these electrons will shift here. You will have this R CH2, CH2O negative, MgX positive, right? So X, let's say here you have Br. After hydrolysis, this will be converted to OH, and that's how you will have the formation of primary alcohols here from the epoxides, right? Okay, from the epoxides you will have the formation of primary alcohols, right? Is that clear everybody? Okay, yes students, now let's study about from the carbonyl compounds, right? From carbonyl compounds, anybody oxidizing agent or reducing agent will use. Let's see how many of you can answer this. Will we use oxidizing agent or we will use reducing agent? If you can answer that, that would be amazing. Will we use oxidizing agent or we will use reducing agent? Any of you who can answer this? Any of you who can answer this? By reduction of aldehydes and ketones, because reverse we want to go. We want to go the opposite side here. Alkanes to alcohol is oxidation. Aldehyde ketones back, reverse, we will do reduction here. So by reduction of aldehydes and ketones will make alcohols, right? And here we need what kind of reducing agents we can use. Aldehyde gives primary alcohols and ketones always give secondary alcohol. Why? Because here this is converted to CH2. So this will be RCH2. This is converted to OH, right? So here, wait a minute, not this one, This one will be converted to OH and this is H will be added here, H will be added here, H will be added here, right? So this one will be converted to RCH2OH. Here H will be added here, H will be added here, this will be converted to RCH2, RCHR and this is OH. So that means 2 degree alcohol will be formed here, 1 degree will be formed here. So always in case of aldehydes you will have primary, in case of ketones you will have secondary alcohols here. Reducing agents you can use catalytic hydrogenation or you can use LiAlH4 or NaBH4, these things you can use, right? But let's see how they will give us the product, okay? So reagent is aldehyde, you are using LiLH4, it will give you 1 degree. Reagent is aldehyde, again LiLH4, you are using ketone, it will give you 2 degree. If you have an acid, right, and you have LiLH4 in excess, then it will give you 1 degree because this is RCOOH. This is also going to give you RCH2OH, right? Here, any derivative of acid will give you 1 degree, 1 degree, 1 degree. That means only the ketones, right? That means the one which has bridging carbonyl group. So here it has a bridging carbonyl group. Ketones has a bridging carbonyl group. That's how you will have the formation of 2 degree alcohol here. Others, when the carbonyl group is terminal, whatever you have here, this X can be OH, this X can be Cl, this X can be anything, right? It will always give you RCH2OH, that is primary alcohol. So with LiAlH4, you will have primary alcohol from aldehydes, carboxylic acid or derivatives of carboxylic acid, but ketone is going to give you 2 degree alcohol. But in case of NaBH4, let's talk about that, okay. Till now we are discussing lithium, aluminium only, okay. Alkyne benzene rings are not reduced by LiAlH4 in ether, but it is reported that double bond can be reduced by LiLH4 in THF in cinnamic systems. This is a very important point. This is a very important point, guys, right? That when we are discussing about alkyne benzene ring, nothing will happen. That means nothing will happen to the double bond when you have LiLH4 in ether, right? LiAlH4 in ether, nothing will happen. Nothing is going to happen in that case. But if you have LiLH4 in THF, then things will change here. Then what might happen here, ma'am? When you have LiLH4 and THF, in this case, if you have a cinnamic system is this system, right? CHO, CH, double bond, CH, PH. Here this double bond also will be reduced, okay? This is a important reaction that they have already asked you, right? Mark it, very important, that in ether nothing will happen. But in case of THF, things will change here, and that too cinnamic system, right? Okay, very good, Manoj. You are talking absolutely right here. Now, when you talk about NaBH4, that behaves totally differently. It is more specific. Why? It does not reduce any other derivative of acid, only acid chloride. It is effective even in protic solvents like alcohols. right? Okay, so that means if you have NaBH4, aldehyde it will give 1 degree, ketone it will give 2 degree, acid chloride it will give 1 degree, but carboxylic acid, esters, or you have amide, it will do nothing, right? It will not only react. Only with acid chloride is that derivative of carboxylic acid that it will reduce. It will not reduce anything else, right? That is a very important point, and based on this also they have asked a question. NaBH4 selectively reduces carbonyl carbon of aldehyde ketones and acid chloride without affecting the double bond. It will never affect the double bond here. These are some of the most important points here that we are writing here. Right now, this particular chart will define it more easily. If you have NaBH4, aldehyde, yes. Ketones, check. Acid chlorides, check. But carboxylic acid, no. Esters, no. Amides, no. Any other derivative, no. Right? LiLH4, all of them. H2 catalytic hydrogenation, all of them. So because of this differentiating point, they ask you a lot of questions, especially for carboxylic acid, that NaBH4 will not reduce, but LiLH4 reduce. Acid chloride, NaBH4 can also reduce, LiLH4 can also reduce. Okay. Now let's talk about this particular thing, that how mechanism works here. Short notes, LH and ether not reduce. Yes, very good, very good. You are also making short notes side by side. That's really amazing, right? So, see NaBH4, now basically what happens, it reacts here, electron shifts here, right? And this D actually will further attack here. That means D will be attached this side, this will have a carbon, this will have a hydrogen here. So, you will have the attachment of deuterium. That means hydrogen that is being added is not from NaBH4. It is actually from the water that you have added, that will be added on the oxygen. So if here you have hydrogen and here you have deuterium, here you will see the attachment of deuterium. Okay, this is also an important thing to remember, right? In case of LiLH4, right, you have water, then again this will attack here. Here if you have deuterium, here also deuterium will be attached. Here you have hydrogen, here hydrogen will be attached. So whatever water you are adding on the next step, that will be added, that isotope of hydrogen will be added. Okay. Let's see this JEE Mains previous year question, everybody. Let's see this everyone. Let's see this everyone. Which of the following combinations is suitable for preparation of 3-methyl-2-butanol? 3-methyl-2-butanol means what? 1, 2, 3, 4. Third position you have methyl. On second position you have OH, right? So this should be formed. Okay. Array. CH3, there should be one hydrogen here, this thing should be there. 2-butanone, this isopropyl magnesium, I can already see that. Acid, aldehyde and isopropyl. Okay, it will take you time, you can solve it one by one and then see the answer, right? Because you know, you can directly see it, you can solve all of them and see if that was formed or not. Directly I can tell you that here C double bond O, this is acetic acid, this is acetic aldehyde. Here if you have isopropyl, from this gave me the hint that isopropyl can be used. So that's why I firstly saw that is there any isopropyl? Yes. With acid aldehyde definitely it will give this one, right? So CH3, this is C, this is CH3, bromide means this is magnesium bromide means MgX. So this is the R part that will attack here, electrons will shift here, right? And it will give you O negative, this is CH3, CH, CH3, CH3 and OH, this will be formed here. So answer will be C is the correct answer here. Okay? Right everybody? So that's how you will answer this, that this particular R group is going to attack here, electrons will shift here, and that's how it is going to give you the desired product here. In the following reaction, now can you see this? This is also your PYQ only. NaBH4 and LiLH4, this simple differentiation, that if you see, this is the ester part, and ester can be reduced by LiLH4, but it cannot be reduced by NaBH4. So based on that, we will answer this, that LiAlH4, if you see, in both case it will not be same, in both case it will not be same, it will be different. Now they have played with you. LiLH4 is going to give you B. B is what? B is written here. It is written here, and there it is written there, just to confuse you. Okay. So it will reduce all of them. This will be converted to OH, this will be converted to OH, this will be converted to OH. So all of them will be converted to OH, OH, OH. Right. Here this will not be B, so this is B. And in case of C, this will remain as it is, this is converted to OH. So this will remain as it is, this is converted to OH. So answer will be A is the correct answer here. Okay, everybody, A is going to be the correct answer in this case. Right, everyone? Okay. Yes, students, now let's discuss the physical properties of alcohols. Right? Let's discuss the physical properties of alcohol, everyone. Let's talk about that. Let's talk about the physical properties of alcohols, right? The OH group of the alcohol has profound effect on physical properties. Let's see how, right? Alcohols are colorless. First thing is colorless liquids with specific smell they have. They are soluble in water due to hydrogen bonding, because so you have R, OH, and with water you have OHH. So they will show hydrogen bonding here. Because of this hydrogen bonding, they are quite soluble in water. They are partially soluble in organic solvents, they are partially soluble, but in water they are completely soluble. They are liquid in nature up to 12 carbons. Up to 12 carbons they will be liquid in nature. Melting point and boiling point is directly, this is very important point, that melting point and boiling point is directly proportional to molecular mass. If molecular mass is increasing, melting or boiling point will also increase in this case. But when the number of branches are increasing, then the melting point or boiling point will decrease. Boiling point of alcohols are higher than the equivalent ethers. Now why so? Because of hydrogen bonding. This is also an important point, that in case of ether, ROR, let's say this example, CH3O CH3, this oxygen, if you see that this is another molecule of CH3, this hydrogen cannot form hydrogen bonding with this oxygen, because the hydrogen that is forming hydrogen bonding with the oxygen also should be attached to a electronegative element. Only then that hydrogen can form hydrogen bonding with the oxygen. That means that this particular hydrogen will not be effective here. So ethers will not show hydrogen bonding, they will only show simple dipole-dipole interactions. Okay, so that is the reason boiling point of alcohols are higher than the ethers. Now if you see the colors and all, then state lower members are liquids while higher members are waxy solids. Lower members are liquid because in higher members the hydrogen bonding further increases, right? So color is almost colorless. Odor, faint odor except glycerol, right? Very less odor they have, except faint, that means very less odor, but glycerol does not have any odor. Right? Solubility, they are very soluble in water due to hydrogen bonding, and as the molecular weight increases, solubility decreases. Now can you tell me why? See, here you have one CH3OH. This is the hydrophobic part. This is the hydro-loving part. Why? Because this shows hydrogen bonding. If this particular part increases, because of the chain here increases, then this hydrophobic part increases, and that is the reason the solubility decreases. So when you increase the molecular mass, the hydrophobic part increases, hence the solubility, that means the extent of hydrogen bonding will decrease, so solubility will decrease. Flammability means whether they are flammable with blue non-smoky flame, right, which is a good thing. Boiling point, higher boiling point than comparable molecular formula compound. So why? Because they have a very good hydrogen bonding with each other, with the molecules within themselves, they have a very good hydrogen bonding. So as compared to alkanes, ethers, they show very high boiling point. Okay, right everybody? Boiling point is directly proportional to molecular weight, and boiling point is inversely proportional to the branching. That also you should know, right? Okay, that's why we say neo has minimum, then iso, then you will have n, right? Because less branching means more boiling point, right? Okay, so now if you see this here, this is more the boiling, more the molecular weight, more will be the boiling point. So this is going to be the order, because that has a maximum alkyl chain, right? Then in this case, in the isomeric alcohols, this has maximum branching, so that is why minimum boiling point here. So this is N, this is iso, this is not neo, this is tert, right? So more the branching, less is the boiling point here, right? Okay. Now let's talk about that how come the boiling points of alcohols, right? How come the boiling points of alcohol is more than the corresponding ethers? As compared to the corresponding ethers, how come their boiling point is low as compared to that? Okay, let's talk about that. So boiling point of alcohol is more than the corresponding ether because of the hydrogen bonding. If you see, among the alcohol, this hydrogen is connected to electronegative element, and this is already an electronegative element. This hydrogen is connected to the electronegative element, this is already electronegative. This hydrogen connected to electronegative, this is already electronegative. But in case of ether, there is no hydrogen that is directly connected to oxygen. That is the reason it will not show hydrogen bonding. Alcohols have higher boiling point than ether and alkane because OH group allows alcohol molecule to engage in the hydrogen bonding, and that is why they have higher boiling point. Okay, right everybody? Now let's talk about the acidity of acidic strength of 1 degree, 2 degree, 3 degree alcohol. If you remember, this also we have discussed in GOC as well. So I'll just polish this, I'll just recap this for you. Here you have 1 plus I effect, here you have 2 plus I effect, here you have 3 plus I effect. And acidity means this is negative, positive, negative, positive, negative, positive. More is the stability of carbon ion, more will be the acidic strength, right? So this is a carbon ion. If to a negative you donate the electron, it will become unstable. If to a negative you take out the electron, it will become stable. So that means you're donating it from 3 sides, it is becoming unstable, so its acidic strength is lowest. Here it is because from 2 sides, here it is only 1 side and you're donating, so this is maximum acidic among these 3, and that we have answered based on the acidic strength here. Based on the inductive effect of the methyl groups, right? Okay, that's how you're going to answer this. Now let's see, based on physical properties, how can you answer these questions? Yes, hydrogen bond, Tarun, definitely hydrogen bond. Yes. So let's answer these. Let's answer these things. Dimethyl ethers and ethanol have same molecular weight, but boiling point of ethanol is greater than dimethyl ether. Cause of this is, right? They are saying dimethyl ether and ethanol have same molecular weight, but the boiling point is of ethanol is greater because of less number of branching due to hydrogen bonding in the alcohols. So answer is very good, Manoj. C is the correct answer here that you can answer. What is the correct order of boiling point of alcohols having the same number of carbon atoms? If it has the same number of carbon atoms, then what is going to be the order here? If it is going to have the same number of carbon atoms, right? Same number of carbon atoms, more the branching, less is going to be the boiling point. So it will be 1, 2 and 3 degree, right? So answer will be A is the correct answer here, right? Branching is inversely proportional to the boiling point, okay? That's how you're going to answer these things. Okay, tell me guys if that is clear to all of you or not, right? Tell me guys. Now we'll see, I don't think so full reactions of alcohols will be able to complete, right? See, some of them are repeated only, but we'll see that how many of, at least if we're able to do type 1 also, that is great. Okay, so we'll see how much we are able to do today, right? Okay, rest of it I'll take up in phenol only. Some part that we are left with I'll take up on Wednesday's lecture. Wednesday, don't worry, we will take lecture 8 p.m. We'll start the lecture, we'll do lecture till 11. Next lectures are going to be 3 hours. Okay, this lecture I took short because see, on Thursday something really interesting is coming for you, right? Your very nice practice we are going to do on Thursday. So something really important is coming on Thursday, right? On this YouTube channel we'll do that, right? And for that we have to keep our slots free for, you know, not Thursday. Yes, it is happening on Thursday or Friday. No, it is happening on Friday. Yes. Yes. So Wednesday and Thursday I'll keep the slots free, right? Okay. Yes. Yeah, it is happening on Friday. My bad. It is happening on Friday. Yes. Okay. Yes, everybody. So let's talk about this now. What we have in general, alcohol shows the following types of reactions. So 2 types we have. The Thursday, Friday the session will be there. We will see that what will be there, right? But for now, I just want to keep your slots free for that. So that's why I took the lecture today. So type 1 is involving breaking of COH bond. This bond will break. Type 2 is involving the breaking of OH bond. Okay, so let's talk about the first kind of reaction, that is COH bond will break. That means this particular bond will break. Then what are the kind of reactions that it can show you? So first is dehydration reactions. So elimination of water from the alcohol forms OH, 1 carbon, and this adjacent carbon is known as dehydration, and these all the reactions we have already done. That's why I feel that it should be completed by today, but let's see, okay. Phenol is going to be something new for you, right? Because in phenol, yes, you will see new reactions. So this OH will leave, this H will leave, here you will have the formation of alkene here, right? Because here we have the breakage of this carbon and this OH bond. That is the reason this is under type 1 type of mechanisms. Primary alcohols, when heated with concentrated H2SO4, they undergo intramolecular dehydration. That means OH will leave, H will leave, and this will shift here. This is beta elimination that you have here, right? For example, you talk about this one, and according to Sedzeff rule, which will be formed, just we have done it in the previous class, right? You will have the formation of more alkylated as a major product here. So this will leave, and you will have the double bond here. In this case, this will leave, this hydrogen will leave, and you will have the formation of a double bond here, right? And if you see some reactions like this, here OH will leave from this side, H will leave. See, this is where OH is leaving, that is alpha, this will become beta, this will become beta, this will become beta. Right, so we need more alkylated, so hydrogen will be eliminated here to have more alkylated product as a major product here. This is the major product because it is more alkylated product according to the Sedzeff rule. Yes, PCC, PDC, yes. That we'll talk about, don't worry, that is here only. In the oxidation we'll talk about that. Dehydration of alcohols follows three-step mechanism. Firstly, you will have protonation, then you will have formation of carbocation, then formation of alkenes, right? All you have to remember here that we have done this already. See, we have already done this in alkyl and aryl. It is same as that. Just remember that it is E1 beta. E1 beta means adjacent carbons. E1 means it is having the formation of carbocation here. So the rearrangement will take place if possible. So here when you take this out, this carbocation is formed when H is attached here, and then this will take it out, right? Protonation means here firstly H will be protonated, this will become positive, then this will leave, right? So you will have the formation of carbocation, that is a rate determining step, right? Now from this two things are possible. This is alpha, this is beta, this is beta. Either proton can be donated from this side or from this side. So proton can leave from either of the sides. It will choose that side which is more alkylated as the major product. Okay, so that is your Sedzeff rule. More substituted alkene is always the major product, and the ease of dehydration because carbocation is formed here. So more the stable the carbocation, 3 degree alcohol will have a more stable carbocation. So the ease of dehydration is 3 degree, then 2 degree, then 1 degree. That is going to be the ease of hydration, right? Then Sedzeff rule, the more substituted alkene, this we have done, yes. 3 degree and 2 degree alcohols react via E1 mechanism, while 1 degree reacts via E2 mechanism. This is very important. That 3 degree and 2 degree if you have, they will have the formation of carbocation. In this 1 degree, you will have only this is one step mechanism. You will have the formation of transition state. You will have the formation of transition state in case of E2 mechanism, that is for 1 degree alcohol, right? Okay, so this is 2 degree alcohol, so Sedzeff product will be formed as the major product, right? Carbocation will be formed, rearrangement will take place if possible, so you will have a double bond here, and that is going to be the major product here, right? Okay. So what are the other dehydrating agents that you can use? Al2O3, same. P2O5, same. THO2, same, right? So these are some of the other dehydrating agents that you can use. But here remember one thing, that concentrated H2SO4, Al2O3 and P2O5, they will give you Sedzeff product, that means more alkylated will be the major. But if you have thorium oxide, that is THO2, it will give you Hoffman product as a major product. That means less alkylated substituted product will be the major product. So double bond is at the corner. You have only one alkyl substituted on this alkene, so it is Hoffman product is the major product here. Right? Okay. Yes, everybody? Okay. Now, let's talk about this one. Find the product of given reaction. So, this is the given reaction. You have to find the products here. Right? You can see this is 2 degree. So, that means more alkylated. This here will be positive. So, carbocation that you will have. Tell me guys, beta, it will follow as E1 or E2 mechanism. What kind of mechanism it will follow? Anybody? What kind of mechanism it will follow? It will follow E1 beta. Carbocation will be formed here. Because it's a 2 degree alcohol. In a 2 degree alcohol, carbocation is formed, right? And we will actually do methyl shift here. Methyl shift. Why? Because we want to make a stable carbocation. This is a 2 degree. If you shift methyl here, this will become positive here. This will become a 3 degree carbocation, which is more stable. Then you will have beta is, this one is also beta. This one is also beta. So you'll have more alkylated carbon as the double bond as the major product. So this is CH3. If you put double bond here, if you have double bond here, this is less substituted. If you have CH3 here and double bond here, this is more alkyl substituted. So answer will be this one. C will be the correct answer. Something like this, CH3, then you have double bond, then you have CH3, then you have single bond, then you have CCH3. Yes. So C will be the correct answer here. Is that clear, everybody? Substituted alkene more stable, so we should do methyl shift. No. I am telling you that, see what we have seen here. That 2 degree and 3 degree alkene will follow E1 mechanism. That means carbocation will be formed. That means if rearrangement is possible, then we will do that. Carbocation we will make. So what you see here is that in this case what you have, this is 2 degree. This is connected to that carbon which is further connected to 2 more carbons. So it is 2 degree. It will form a carbocation. Now because this carbocation is 2 degree, so we'll have methyl shift to convert it into a 3 degree carbocation. Now you will think that whether this beta should leave hydrogen, this beta should give hydrogen. Now you will think about ZZ product, that this ZZ product will be more stable because more alkyl substituted alkene is more stable. Okay, so both the things, rearrangement is a different thing and ZZ rule is a different thing that you will apply once you have a stable carbocation. After that you will think about ZZ rule. Okay, got it? Yes, everybody, wait a minute. Oof, I didn't see one thing only. Oof, my bad. This is also beta, na? This is also beta. This we forgot only. Then why? Oh, this is also beta. Then which will be most alkyl substituted? If you have a double bond here, then that will have 4 alkyls here, right? This will be major substitution. If you have a double bond here, it will be 1, 2, 3. 3 alkyls will be there. If you have a double bond here, then only 2 alkyls will be there. If you have a double bond here, then you will have 3 alkyls here. So this will be the correct answer. My bad. This will be the correct answer. Right? Yes. Manoj, D is the correct answer. I didn't see that there is one more beta carbon here. Excellent. Right? When your students answer you, then that is the most happiest thing for a teacher. So I'm so happy that you're able to identify that yes, I did a blunder here. Right? So yes, that is the beta. So this will be highly substituted alkene. Right? So answer will be D is the correct answer here. Okay. Next question, the product of following reaction. What is the product of following reaction? So if you see this here, this one is also going to be quite interesting. Firstly, what we know is that we will have the formation of a carbocation or not. See, now you will say, ma'am, it's a 1 degree alcohol. No, carbon is connected to that carbon, which is further connected to only 1 carbon. So this is going to be primary alcohol only. But the thing is that this carbocation, because of the cyclic ring, is quite stable and it can further lead to ring expansion. It can further lead due to ring expansion. That is why this can be there. Now that is why carbocation we have formed. Why? Because here if you form a carbocation, there is a chance of ring expansion. That's why you will form a carbocation. This will be 1, 2, 3. What will happen here? You will have 1, 2, 3. The bond of 2 and 3 will break and this will attach and this will be shifted to second position. So you will have this kind of situation, right? This kind of situation. Okay. Yes. Now this is beta, this is beta. From there you can have the formation of this particular bond. That is C will be the correct answer in that case. Okay, C will be the correct answer in that case. So answer will be C is the ring expansion only we did na here. From the carbocation ring expansion we did. Okay, from the carbon what we did is ring expansion. है ना? Okay, this follows E2 only because this follows E1. This also follows E1, not because it is primary, but because there is a chance of ring expansion. Always 5-membered ring is less stable as compared to 6-membered ring. 5-membered ring is not a stable ring. 6-membered ring is a very stable ring. So when the stability is going from 5-membered to 6-membered, it will be like, I don't want to follow E2. I will follow E1 only because I have chance of ring expansion. So it will follow E1 mechanism and it will have the formation of carbocation only because 6-membered ring is possible. If 6-membered ring is not possible, then it will not follow E1, right? Okay? Because 6-membered ring is quite stable ring, right? Cyclohexane ring is a very stable ring. Okay? That's a good question, Manoj, but the thing is that it's a 6-membered ring is formed here. So rather than sometimes these things might happen, that's why I have given you this question here, because in this question things will change, right? Okay. Yes, everybody, tell me if that is clear. Tell me if that is clear. Acha, now let's talk about substitution reaction. So substitution reaction with halogen acid, PCl3, PCl5, SOCl2, SOCl2 with pyridine. Most of it we have done, right? But let's do it again. Some of the new things also I'm going to tell you here. Substitution reaction of alcohol, OH group of alcohol is placed by halogen by either SN1 or SN2 mechanism. In SN2 you will have transition state, in SN1 you will have the formation of carbocation, right? So reaction with halogen acid, that means HX, what will happen? This X will be replaced by, this OH will be replaced by the X here. Primary alcohols react by SN2 mechanism, but same as that one. Do you remember this one? 2 degree and 3 degree will react by SN1. That means by making a carbocation, right? Okay. So next is which one has maximum reactivity, because HX, because we know fluorine, chlorine, bromine, iodine. Here the length of iodine is, because the size of iodine is large, so that's why it is easy to break that bond. So here you will have HI, then HBr, then HCl. HI is very easy to break, so it will have the maximum reactivity, HI, HBr and HCl. Reactivity of alcohol, because here you have the formation of carbocation, right? That is the reason tertiary, then secondary, then primary is the reactivity of alcohols here. In SN2 mechanism, what will happen in case of SN2 mechanism when you have the formation of carbocation? But this we have already done, so we don't need to do it again and again, okay? Okay? This is same, that if SN2 mechanism happens, you will have the formation of carbocation here. If there is SN1 mechanism, SN2 mechanism, you will have the formation, there is no carbocation, there is transition state, right? That will attack here and by that time this will leave. But in case of SN1, you will have the formation of carbocation firstly, and then that carbocation will have the attack of X negative here. Right, so both the mechanisms are possible here depending upon different things, that what is the alkyl halide you have, depending upon that you will choose which mechanism you will prefer. Okay. Next is general reaction, ROH with HBr, Na, Br, H2SO4. Br will replace this OH here directly and you will have the formation of alkyl halide here. If you have HI, Ki and H3PO4, this OH will be replaced by iodine here, right? Okay. Then guys, 1 degree, 2 degree alcohol does not react with HCl. Now this is Lucas test, that 1 degree and 2 degree does not react with HCl unless ZnCl2. This is a very important line. Or similar Lewis acid is added to the reaction mixture, since Cl negative is a weaker nucleophile as compared to I negative and Br negative. That means if you want to react HCl here, you need ZnCl2, especially for 1 degree and 2 degree. Actually, HCl, ZnCl2, the reactivity is of the order 3 degree, then 2 degree, then 1 degree. So for 3 degree, Zn2Cl2 not important. It's not important, but with 2 degree, 1 degree, ZnCl2 is important. That means without ZnCl2, this reaction will not take place only. This reaction will not take place without ZnCl2. Okay? Understood everybody? This reaction will not take place without ZnCl2. So Lucas test, that is the test of distinguishing 1 degree, 2 degree, 3 degree alcohol, where what we do, ZnCl2 and HCl we use, that is called as Lucas reagent, and turbidity is formed here, that is cloudiness appears here. So in 3 degree it will appear immediately, that is why the order is 3 degree, then 2 degree, then 1 degree. 2 degree it will appear after 5 minutes, and for 1 degree it will appear after 30 minutes, and that too if you have prolonged heating, only then this will appear. Otherwise at room temperature nothing will happen here, right? So that is the reason 1 degree and 2 degree need ZnCl2, and that too very after long time this reaction will take place. Okay, right? Then the next is reaction with, these are the last kind of reactions that I'm going to do. After that, rest of the things we will do in the next class. Okay? Because we are not left with that much, we can do it in the next class, right? 1 degree, 2 degree alcohols react with PCl3, but 3 degree alcohol does not, right? So 3 degree alcohol does not react with PCl3, but 1 degree, 2 degree alcohol can react with PCl3 to give what? With PCl3 it will give H3PO3 as the byproduct and RCl. This we have already done in alkyl halides, right? Okay, that's how it will react, and it will give you that's how it will react, and it will give you, which one? This you don't need to do, right? This you don't need to do, right? Okay, this we have already done in alkyl halides. Reaction with PCl5, this will give you POCl3 and HCl as the byproduct. And here it will be same RCl as the main product. Okay, here again this OH, because it's a 2 degree alcohol, it can react and give you isopropyl chloride with PCl5, right? Okay, right everybody? Now in PCl5 what happens, mechanism not important for you, right? But if you want to see that, I can show you that. Mechanism with SO2 pyridine, so we will definitely do, है with pyridine. SOCl2 mechanism with pyridine or without pyridine is very important, that we will definitely do, and that I am thinking to do in the next class, right? So we will do that in the next class. Okay, so this I will just teach you, because now Namrata ma'am is going to take the class. Let me see. Yes, Namrata ma'am's class will be there. So I'm gonna end the class now. So here alcohol will attack on the phosphorus, because phosphorus is electron deficient. This Cl will be eliminated here, right? Then what you will have, this oxygen, because it is bonded to 3 bonds, so it will be positive. Then what will happen, this particular Cl will attack on hydrogen, it will take away the hydrogen here, right? And these bonds will shift here, and hence you will have the formation of this PCl4 1 to 4, and this is OH. Now internal attack will be there. These lone pairs are going to attack on the phosphorus, because phosphorus is electron deficient, right? So it will attack on the phosphorus, and here you will have a double bond and positive. Again the Cl will attack on this particular alkyl group. These electrons will shift here. You will have the elimination of POCl3, and RCl will be formed here. Okay, POCl3 and RCl will be formed here. Okay, everybody, tell me. Let me see if Namrata ma'am has her lecture at 6. So I'll just end the class now. Wait a minute. Wait a minute. Okay, she has scheduled her class to 6:30. Chalo. Then we have time. Just give me a minute. Okay. So let's do as much as we can do. Reactivity with SOCl2. Now see two kind of reactions that can take place. If you don't have any pyridine here, this is very important. If you don't have any pyridine, there is no base here, it is the best reagent because products are gaseous, leaves the reaction, okay, that we know. But here if you don't use pyridine, then it is going to follow SNI reaction. That means intramolecular mechanism it is going to follow. Let's see how, okay. Let's see how. So this is SOCl2, this sulfur again is electron deficient, these lone pairs are going to attack here, right. Then this particular bond is going to shift here, right, okay. Now if you see, wait a minute, okay, this is going to attack here, you will have, wait a minute, this is going to attack here, wait a minute. See, with and without pyridines, things will change here, okay? With and without pyridine, things are going to change here, right? Okay? Things are going to change here with or without pyridine. Let's see how. Let's see how. Okay? Let's see. This is S. So what is going to happen here? What is going to happen here? This particular bond is going to attack here. When this attacks here, one Cl negative will be eliminated from this side and here one H will be eliminated from this side. Okay, and hence you will have this oxygen attached to this sulfur here, this oxygen attached to this sulfur, double bond O, and this is Cl here, right? Okay, HCl will be eliminated. This is the thing that you will have. Now, what you will have here, this Cl internal attack will be there. This Cl is going to internally attack on this carbon and this bond is going to shift here and you will have the elimination of SO2 and this Cl will be attacked here. So, by the retention of configuration, you will have the formation of RCl. Okay. Now see one thing. In case of pyridine, now you just see this thing that okay, Cl firstly will leave from this side, right, and here H will leave, these lone pairs are going to attack here, it will attach, and after that Cl is internally shifting here. That is the thing, intramolecular delivery of Cl negative, intramolecular attack of nucleophile is happening, okay, that is why it is called SNI mechanism. But now see, if you have pyridine here, things will change. In case when you have pyridine here, it is going to show SN2 mechanism. Let's see, ma'am, but why, ma'am? What will change in case of pyridine? Ma'am, why in this case products will be same, OH will be reacted, and here you will have inversion. In case of SN2, there is transition state formed and inversion of configuration is there. So, inversion of configuration will occur, right? Okay, that's why OH was earlier here and now inversion of configuration Cl will be here, right? But in this particular case, this OH is here and this is, wait a minute, not this one, wait a minute, this one. This OH is here and this is Cl. So there is retention of configuration here. Retention of configuration is very important point, okay. But if you have pyridine, then in that case there will be inversion of configuration. Now ma'am, the question is, ma'am, why it is following SN2 mechanism? Ma'am, what is the need for it to follow SN2 mechanism? Right? Okay. Yes, everybody. Let's see what is the need for it to follow SN2 mechanism. Right? Let's see that. So what same thing will happen just like before. This negative, this lone pair will attack here. Cl negative will leave from this side and this H will leave from this side, and hence you will have basically, wait a minute, yes. Yes. This Cl negative will leave from this side. Now see, this is O, oxygen is attached to this sulfur, double bond O and Cl. Now see, here you have H, here only Cl negative has left. Now, here what was happening? Here this hydrogen also left here. Why? No one else is there to capture this hydrogen. No one else is there. But what if I have a base here? If I put a very strong base which abstract this proton here, that means if you have some other base that can abstract this proton, so HCl will not be eliminated with this Cl. Something else will happen. So let's see what. Right? So here you have Cl. Now this base is going to attack on this particular hydrogen. It will abstract the hydrogen. These electrons will shift here. This hydrogen will be taken by the pyridine, which is a good base. Right? So here you will have OS this. Now can you see one thing? There what was happening? Right? Internal Cl was attacking, this particular Cl was attacking on this electron deficient site, right? Now this internal Cl is not able to attack on this electron deficient site. Let's say how, right? Why this is not able to attack? Because now this Cl negative is alone. When you have not used pyridine, then the Cl was with hydrogen. Then it was not alone to attack. Now this Cl negative is alone to attack. Now this Cl negative, it's like this Cl negative is actually not more, this is only, there is only sharing like that. That means this is only like more partially negative, this is partially positive. That's how it can attack here. This is a proper nucleophile with a negative charge. So this is a stronger nucleophile. This will attack here. This same bond will shift here. This Cl negative will now be eliminated, and hence you will have the elimination of one Cl negative here, and you will have inversion of configuration because Cl will not attack from this side. Cl will attack from the opposite side. Okay. Tell me guys, this is a very important point, that in case of pyridine will abstract the proton. That's why that particular proton will not be linked with the Cl. That's why Cl negative outside is free to attack. But in case of when you don't use pyridine, in this case when you are not using any pyridine, in this case this H will be eliminated with Cl negative. This Cl is not free to attack. That is the reason here internal Cl will attack on the carbon and intramolecular substitution will occur. But in this case what will happen? SN2 mechanism will take place here. Right? Okay. Tell me guys if that is clear. This is a very important part regarding this reaction is Darzens reaction, and Darzens reaction with the nucleophile, with pyridine or without pyridine behaves in a very different manner. Right? Okay. No, 7-membered ring is less stable as compared to 6-membered ring. Right? Okay. Just give me a second, guys. Just give me a second. Just give me a second, guys. Something really important. Okay. Okay. These mechanisms are really interesting. I hear like a story. Yeah. So, the order of reactivity of following alcohols towards concentrated HCl, right? So, towards concentrated HCl, what will be the order, guys? Okay. So, towards concentrated HCl, what will be the order here? So, directly how we will solve this, right? If you see in this case, carbocation is formed, and we know that here you have negative, 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 that means electron withdrawing. Here you don't have any electron withdrawing, here there is resonance, right? So, carbocation stability here it will be maximum, here because you are withdrawing this will be minimum, right? Here the electron withdrawing group is very near, so it will have minimum stability. So, the stability of these carbocations is going to above order, therefore the order of reactivity of alcohol will be in the same order here, that is 4, 3, 2, 1. Okay, right? So answer will be 4, 3, 2, 1. So C is the correct answer here. You just have to check the stability of the carbocation, and that's how you can answer this particular question here, right? Okay, that is based on GOC, that I am not going to teach you here. That's why I did this question in a hurry. Now this question is based on reaction part. An unknown alcohol is treated with Lucas reagent. An unknown alcohol is treated with Lucas reagent to determine whether the alcohol is primary, secondary or tertiary. Which alcohol reacts fastest and by which mechanism, right? Which alcohol? Tertiary alcohol reacts fastest. But is it by SN1 or SN2 mechanism, everybody? Yes. Is it by SN1 or SN2 mechanism, everybody? It is by SN1 mechanism. That means there is a formation of carbocation here, right? Okay, tertiary gives carbocation, secondary will form by carbocation. So, tertiary alcohol by SN1 mechanism is the correct answer here, right? Okay. Now, guys, you can take break for 15 minutes, right? I'll do rest of the part in the next class, right? We are left with type 2 reactions, right? That we'll do in the next class, right? And that's it for today. Let me see how many of you can do this homework. This is the homework for today, and I'll see how many of you do your homework. Distance, number, power. Yes, definitely. Yes, DNP rule. Distance, number and power. Very good. Yes, you will follow that I have already told you in GOC, right? Okay. So, which of the following alkenes will give same product by any method out of hydration, hydroboration, oxidation, oxymercuration, demercuration? You have to tell. Which will give, following alkanes will give same product by any method. By any method they will give you the same product, right? Any method, hydration, hydroboration, oxidation, any method you choose, that will give you the same product, right? Okay, so let's see who will give the answer here, right? This will be CH3 here, right? And let's see how many of you write the answer in the homework, right? And guys, before going, remember that we will have our homework you will have to write down in the comment section. I'll wait for your homework in the comment section, right? And before going guys, our online MVSAT scholarship registrations are live, right? Because so many of you are not able to go to the offline center and give the test. That's why here we have online MVSAT, and the dates are 21st October to 28th of October, right? So register yourself right now, because if you are right now you are delaying it, then after that there will be no other chance that will be given to you, right? Registrations are free of cost at the facility of your home. You can give this, and if you are among 2.5 lakh students, then you will get 100% scholarship. You will get 100% scholarship, one-on-one counseling, 150 crore worth of scholarship and 2 crore worth of prizes you will get here, right? All you have to do is register yourself. The link is in the description. I'll see how many of you register yourself. If you recorded video first time in live, just want to say thank you. Amazing session. Thank you so much, Darshan. Don't worry about the view count. There are a lot of people watching. Thank you so much, Darshan. That means a lot to me. That means a lot. It's just one thing I would advise and request all of you to do is, if you watch this on recorded version, just drop a comment, drop your homework, okay? That will make me very happy that yes, there are students who are watching it, there are students who are dedicated. When I give them the homework, see, consistently I am giving you the homework, so consistently you also should do your homework, right? Okay, yes. Okay then guys, I'll see you all in the next class. Till then, bye-bye, take care, bye-bye, and I'll see you all on Wednesday, 8 p.m. and that is going to be lengthy lectures, 3 3-hour lectures on Wednesday and Thursday. So be ready for that. Till then, bye-bye, take care.